All right. So we're talking about the square roots. We already practiced with finding perfect squares. So we'll just jump right into one here. We're going to solve this together. We're going to solve the quadratic. And here's the one that we're going to take a look at together. I'll call this part A. We're going to do x squared minus 5 equals 4. Okay. Here's a very basic one. How do we even know that this is a quadratic to begin with? What is it about this that's so special that makes it a quadratic? It has a degree of 2. Very good. Okay, awesome. So if I want to solve this for x, I want to isolate the x. I want to get that by itself. I want to get this whole part by itself. Anybody have any good thoughts as to what we can do? Yeah, Cody, what do we do? Yeah, we're going to add 5 to both sides. We're going to add 5 to both sides. And that's going to give us x squared is now equal to 5 and 4 is 9, right? All right. Now, does 9 look like a nice square number? It sure does, right? Remember, the first squares are 1, 4, 9. What was the next one? 16. What was the next one? 25. Then what? Then 36. Let's write a couple of these out. Then the next one? 49. Then what? 64. Then what? 71? I think it's 81, isn't it? Right? And then what? And then 100. Then what? 121. Then what? 144. Good. Then what? 169. Then what? Okay, we get kind of lost after that, right? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 13, right? And that's pretty good for now. We should know up to the 20, the first 20 perfect squares. We should have those. We should. We already know the first 13. There's only a few more, right? Okay, now, it says here x squared is 9. But I don't want x squared, right? I want actually x. So here's what we're going to do. We're going to take the square root. This is the symbol for the square root. So now x could either be plus or minus 3. And I want to talk about why it can be either of those two. Okay? The reason it can be either of those two is because if I took negative 3 and multiplied it by a negative 3, I would get a positive 9. Is that true? It could also just be 3 times regular 3, positive. That would also be 9. Notice that these two are the same number. Is that correct? That's why there is a total of 2 answers. One of them is positive 3. The other is... Okay, what do you think so far? Easy, medium, or hard? Easy, right. Okay, let's do B. Check this one out. What if I said x squared plus 7 is equal to 4? All right, x squared plus 7 is equal to 4. Well, I want to isolate the x squared part. It's a quadratic. So who's got a good idea? Everybody subtract 7, subtract 7. Here we go. X squared is now equal to, what's 4 take away 7? Negative 3. All right. We run into a problem here. There's no solution. Why is there no solution? Do we really understand why there is no solution? Okay, Cecilia, why is there no solution? Yeah, because when I have a square number, if I take the square root, okay, there is no number out there, no solution. There is no number that I could square and get a negative 3. So whenever you have a square root of a negative number, you know you're going to end up with no solution. So far, think of the situations that we've had. This situation here gives us how many solutions? This gives us 2 solutions. Right? This situation here, how many does this give us? This gives us no solution, right? Right? And there might be another case where we could only have just 1 solution, right? Well, who can think of a case where we could have exactly just 1 solution? 0. Very good. We can have just 1 solution, we get 0. Let me give you another example. What if we do this? 25k squared is equal to 9. 25k squared is equal to 9. All right, I want to isolate my squared term, the k squared. So what do I do to the 25? I divide it. Very good. I'm going to divide by 25 on both sides. Divide by 25. Good. So k squared is going to be 9 over 25. And then we're going to square root this, right? So k has to be plus or minus. Okay, what is the square root of the 9? 3. What's the square root of the 25? 5. So I have two different answers, positive or negative 3. What do you guys think about that? 3 is equal to 23. All right, 4x squared plus 3 is equal to 23. Uh-oh. Uh-oh. All right, we want to isolate the x squared term. It's this part right here. So what should I do first? We're going to subtract 3 from both sides. Very good. So that's going to give us 4x squared is now how much? 20. Very good. Now what do I want to do? Divide by what? Yeah, I'm going to divide by 4 on both sides. Divide by 4 on both sides. So now I have x squared is equal to 5. Thank you very much. 5. Very good. All right, now x squared is equal to 5. Take a look at this up here. Is 5 a perfect square? No. But 5 is in between which two perfect square numbers? 4 and 9. Okay? So that means the square root of 5 has to be between which two square root numbers? No. 2 and 3, right? Since 5 is like right here, right? Then the square root of 5 has to be somewhere right about there, right? Do you agree with that? So it's about, is it closer to 2 or is it closer to 3? It's closer to 2 because 5 is closer to 4 than it is to 9, right? Doesn't that make sense? Okay, so we need to figure out what the square root of this is, and we can take it because it's a positive number. So x has to be plus or minus the square root of 5, which is approximately, now I know on the little red calculators, you guys don't have a square root button, but some of you do. So here we go. It's going to be 5, and we're going to take a square root of that. Where's my square root button? Here it is. And notice, what do I get for an answer? 2.24. Now that number is closer to 2 than it is to 3, isn't it? Yeah, so that's going to be 2.24. So I'm going to say 2.24 plus or minus, and how many answers do I have? I've got. Okay, we're going to solve this last quadratic. It says 5 times x plus 1 squared equals 30. Now, how do I know this is a quadratic? Because of the squared term. Very good, very good. And I want to isolate my squared term. So that is all of this stuff, right? This is my squared term. So how do I get that stuff highlighted in yellow? How do I get that by itself? What do I do first? No, I don't distribute. You divide by 5. Nice job, Andres. We divide by 5 on both sides first. That's the easiest thing to do. Check it out. Here's what you have left. That gives you an x plus 1 all squared is equal to, how much is 30 over 5? 6. Very good. All right. Okay, now, have I isolated my squared term here? It doesn't look like it, but I have. I have something squared. It's isolated. So when I'm in this point, I can take the square root. I can take the square root. Now the great thing about that is because when you take the square root of a number squared, they undo each other. So all you're left with is the x plus 1 is now equal to plus or minus the square root of 6. Now 6, let's look back at our little chart here. Is 6 a perfect square? No, 6 is not a perfect square. I'm talking about the red numbers up here, right? It's in between 4 and 9. Those are perfect squares, 4 and 9. So the answer has to be somewhere between 2 and 3, kind of right in the middle, right? Okay, so we know that, all right? So then, have I isolated my x now? No, what should I do next? You got it. Subtract 1, subtract 1. So for an answer, here's what we're looking at. X has to be negative 1, that's right there, plus or minus the square root of 6. And for those, you can actually just leave it just like that. Yep. Now that looks like a really funky answer, but you can leave it just like that. Negative 1 plus or minus the square root of 6. That's called the exact answer right there.